So this first problem almost sounds like a riddle. If I were to walk up to you and say, okay, I'm thinking of two numbers. When I add them, I get 30. When I subtract them, which means difference, so you have to know the meaning of those words, I get 12. What numbers am I? This is a classic example of a way to use systems of equations to find this answer out. And I know what some of you are doing right now. You're going through numbers in your head. And you probably could figure it out after a while. You could say like, okay, let's start with 15 and 15. 15 and 15 adds to 30, but it subtracts to 0. Okay, it's not that. You could be here a while, right? So why sit there trying to come up with things, trial and error, guess and check, when you could use algebra to find it the first way? So here's what you could do. You could do a couple different things. You could just use x and y. And when I take x and y and I add them, I get 30. That's my first equation of my system. What would my second equation be? If I take those same two numbers and subtract them, I'll get 12. There's my system. So whereas in graphing, last test we took, you were done. Just set it up, move on. I want to know what those numbers are, okay? And so do you, I think. So remember what we just talked about? How this is not ready to go. None of these variables are alone. In fact, you have 3 really good options and 1 kind of not good option. Which one do you not want to solve for? I don't want to solve the second equation for y. Because if I subtract x, then y really isn't alone. I'm going to have to divide by a -1, and that's doubling my work. So if you solve for this x or this y or this x, you're in good shape. Okay, I want to get rid of this, so I'm going to choose to solve this equation for x by just adding y to both sides. So I am now rewritten this new and improved equation to be x is really 12 plus y. And the reason I did that is because I had to get it ready. And now it's ready. So I take this expression and I put it in the other equation for x. So I go all the way up here, and I say 12 plus y, and then what? Plus that y equals 30. And then you should know from here to cruise, subtract 12. These are your basic equation solving skills that we learned early in the year, that we've used many times since I just found out that the one of the numbers is 9. Can I really easily figure out the other one is without really having to do any more work? I know when I add the two numbers, I get 30. So what does the other number have to be? 21, right? So the two numbers are 9 and 21. And here's what's kind of interesting. Because we're not talking about graphing anymore, you don't really need to put these answers as an ordered pair anymore. So you're going to see in a minute that I just asked you for the two numbers, 9 and 21. When I add them, I get 30. When I subtract them, I get 12. Got it? Okay? So if I were to give you, I could give you tons of these. The sum of two numbers is 24. Their difference is 2. What are the numbers? Would you be able to do that problem now? X plus y is 24. X minus y is 2. Moving on. Okay? This one's kind of a little bit of a beefed up version of that. The sum of two numbers is 20. But their difference between these two numbers is 3 times the first number and twice the second. So let's think about that. So if I'm writing the difference between two numbers is 20, that's easy. I'm just going to say that one number and this one number plus another number is 20. And this is my first number and this is my second. You know what some people will do? They'll say the first number plus the second number is 20. Man, you're going to really want to start considering using variables other than x and y when you get into these word problems. Because, watch, this says the difference between. So as soon as I see the difference between, I do that. It's the difference between 3 times the first number and twice the second number, and that difference is 40. Got it? So then, kind of ignore this one. I have two options, two really good options. They both have a coefficient of 1. Neither one of them's negative. I'm just going to subtract s from both sides. I'm going to get a new equation of f is equal to 20 minus s. And then I'm going to take this 20 minus s and put it where? In the other equation. And then I'm going to finish solving it. Okay, I'm not going to finish solving this one because I'm going to save that for some of these other problems we're doing. Okay, so are you good on those ones? Sum of two numbers is this, their difference is this, blah, blah, blah. Set it up. Okay? All right, so let's take a look at this one down here. The cost of 3 notebooks, the cost of 3 boxes of envelopes and 4 boxes of notebooks is $13.25. 2 boxes of envelopes and 6 boxes of notebooks are $17. So let's look at it this way. You're at Office Depot. 2 people in front of you. One person in their cart, they have 3 boxes of envelopes and 4, and their total is that. The next person in front of you only has 2 boxes of envelopes and 6 notebooks, and their cost is that. You're standing behind them with 1 box of envelopes and 1 box of notebooks. You want to know the price for each. Do you understand that that's what you're doing is you're setting up a system? Given this information, you could set up a system and solve it to figure out how much 1 box of each costs. Are you ready? So let's do that. So in your notes, go ahead. You probably haven't written anything yet, so go ahead and write this. So 3 boxes of notebooks and 4 boxes of envelopes came to a total of $13.25. Then the next person in line went, and they had 2 boxes of notebooks and 6 boxes. Sorry, that's backwards. I just totally did that backwards. So if you're writing with a pencil, that's okay. Just erase, because I want the numbers to work out. So how many notebooks did we have? We had 3 boxes of envelopes, 4 notebooks. And then 6 boxes of notebooks. Yep. But only 2 boxes of envelopes. And that's what this is. Like, part of this problem is like just deciphering through all this information. There are so many words and they say the same thing so many times. You really just have to kind of look at it and see what they're asking you. All right? Can you see these equations forming in your head? Now, you know what I'm going to tell you? I am not using X and Y for this, because at the end, I want to know how much does 1 box of notebooks cost? And if I'm solving for X, I might go, oh, shoot, what is X? Is X notebooks? Is it? Which, if you go up here and say, let X equal notebooks, let Y equal envelopes, sure. But I'm not even going to do that, because I'm just going to say that 4 boxes of notebooks plus 3 boxes of envelopes came to a total of $13.25. The next person's cart was 6 boxes of notebooks, 2 boxes of envelopes, came to $17. If this was graphing, you would just be done, right? But now you know how to use another method to solve other than graphing. This would be horrible to graph, okay? Because the problem already has a decimal in it. So if I'm looking at which one I want to go for, none of them look great, right? Okay, I definitely, and this is what I did last hour, I said none of them look good, just pick one. And I chose 3. And then I realized as I was working it out, 3 was probably the worst choice. Why? Because if that's what you're solving for, and you have to divide the other 2 by that coefficient, what does dividing by 3 give you on a calculator? A big repeating decimal. And then your answer isn't really very accurate, is it? Because how many 3s did you type in? So I want to stay away from that. What's kind of a safe bet? Would you choose this one? Because number 1, if I choose this, when I go divide 6 by 2, I'm good there. I can divide any number by 2. It's just going to be a half, right? So let's do that. Let's subtract 6n from both sides. That's going to give me a new equation that says 2e equals 17 minus 6n. Then I'm going to divide everything by 2, and e is going to be 8.5 minus 3n. Good so far? So, what was the purpose in doing that? I got it ready. Okay? Now, I'm going to kind of put a little line through that because I don't want to mistakenly take that and put it in for that e. Because I have to put it in the other equation. Okay, go with me. This is a definite calculator lesson. Okay, you're going to be for sure using calculators for this. 4 times n, which I'll put in a minute. Nope, sorry, I won't. And we're putting it in for e. So 4e is staying. Plus 3 times e. Jeez Louise. Feels like it should be a Friday, huh? It's only Wednesday. 4n plus 3 times e equals 1325. And what is e? 8.5 minus 3n. How do you know you plugged the right one in? Because there should only be n's in your equation. Not an n and an e. Because then you'd be like, well, wait, which one am I solving for? There's both. There should only be n's. Okay, so we're going to multiply this, and we're going to say 4n plus, this is going to give you 25.5 minus 9n. Okay, this is a little bit of pain in the butt, going through a lot of work, but it's not hard. 4n plus negative 9n is negative 5n. And then I'm going to subtract this 25.5 from here. And that's going to give me a negative 12.25. You're doing all this on your calculator. Wow, let's keep going. Man, finally, I get to the point where I divide. And when I take my calculator and I divide 12.25 by 5, I get 2.45. Okay. What does that mean? Oh, hey, it's pretty convenient that I have an n there. Because if that was an X or a Y, how would you know if that was the notebooks or the envelopes? So today I want you practicing using variables other than X and Y because I know that each notebook costs $2.45. What could I do to figure out how much a box of envelopes cost? Take that $2.45 and put it anywhere. So I'm going to say 4 times $2.45 plus 3e equals $13.25. Man, $2.45 times 4 is 9.8 plus 3e. This is just like busy work, right? 9.8 minus 9.8, 13.25 minus 9.8 is going to give you 3e equals 3.45. Whew. That's why when I give you these problems, I don't give you like 15 of them. Okay. Whew. So, what's your answer going to be? On the test that I checked, remember how the last time it was, what ordered pair? What ordered pair? I need you to say, each box of notebooks cost $2.45, and each box of envelopes costs $1.15. If you wanted to make sure you were right, what could you do? Check. Do you know what I mean when I say check? You plug it back in here, you plug those numbers in both, and if they are yes and a yes, you found the right amounts. Okay? Do you understand that? Okay. The last example I'm going to show you, because this is an example of an application problem in, go ahead and put this, standard form. You guys know the difference between the two, right? Now, standard form versus slope-intercept form. Slope-intercept form, I bet you guys can do in your sleep, right? Okay, so let's take a look at a slope-intercept form problem. Okay, so everybody got that written? All right, slope-intercept form is going to look like this. And then we're done. Okay. that's where I would say, it costs $10 or $18 plus $3 fee. Okay? For company A, whatever it is. You can make up whatever you want in your mind. It could be rentals for canoes. It could be app download, whatever. GameStop. Company B, okay, and this is always like cost comparison. Cost B is no initial fee. And so that means usually that because there's no initial fee, that your monthly is a little bit what? A little higher, okay? So we'll say that's 20 per whatever. Per thing. I'm going to get real specific here. Okay? So what are your two equations? Company A, go ahead. Yep. Yep. Y equals 18x plus 3. What's the other one? Y just equals what? 20x. Okay? You could say C for cost is equal to $18 per thing plus 3. Or the cost here is only $20 per thing. C for cost. H for hours. E for envelopes. Whatever you want. Okay? So now this is what's a little bit weird. Solving a system with substitution in slope-intercept form, kids always are like, I don't know what to do. Okay, here's why kids don't know what to do. Because there's two things that are ready for you. So please listen, because this is probably going to be the hardest part, is solving the slope-intercept form ones. So my option is either to take this 20x and put it in there, or take this 18 plus x plus 3 and put it there. And it doesn't matter because they're going to be the same thing. Watch. It's going to give you 20x equals 18x plus 3. Got it? So here's why people are confused. Because there's an x on both sides. And I didn't realize how quickly people forgot what to do with that. Do you know what to do? You have to combine those x's, but you can't until they're both on the same side. So I have to subtract this 18x from here. And this is an ugly problem. I just made it up, so it's not going to even. So 2x is equal to 3. Actually, this isn't too bad. So when I divide both sides by 2, x is going to be 1.5. So whatever we're talking about, things, 1.5 is my x, and then I have to go in and find my y still, right? And then usually what it's going to say, and here's what I want you to think about. Actually, I'm going to change this to hour because I want you to see something. Okay? And then your cost. So if x, that's going to be 1.5, and then as soon as I plug this in, I'll know my cost. Okay? So let's plug 1.5 in here and multiply it by 20. And what do you get when you multiply 1.5 times 20? You shouldn't have to do that on the calculator. What's 1.5 times 2? So this is 30. Okay. 1.5 hours cost $30. But what does that point mean? That's what I get when I set these two companies equal to each other. So if I say to you, which company would you rather go with? And you would say, well, if I was going for 1.5 hours, it's going to cost me $30 at both places. So at an hour and a half, doesn't matter. That's what that point means. So when you see these problems, and then in bold, it's going to say, well then, if this is when they're equal to each other, what number of games would it make more sense to be a member as opposed to a non-member? So you have to pick either a number below 1.5 or above it, plug it into your equations, and see what is cheaper. These are typical cost comparison problems. So 1.5 hours is when they both give you the same price. Before then, it would be this company better. And after 1.5 hours, this company would be better. Do you understand? All we're doing is setting up and solving the equations today A system of equations, by the way, has two equations. Like a lot of people on their first test just kind of wrote one equation and we're done. So there's nothing really to solve if you only have one equation.